Testing, testing. Good morning, good morning. How is everybody? There's only a few viewers, and my money is on the fact that everyone is still asleep. Because when you don't have to wake up early and you're a young kid, you just stay up super late all the time. Can you guys hear me okay? It seems like that audio is good. Still have to deal with the delay. I've tried so many things to try and fix it. You're so bored that schoolwork is the best option. Maybe that's how we get kids to enjoy school more. We get them to be so bored that there's nothing else for them to be able to do, and they're just forced to do it then because there's nothing else to do. That's hilarious, Bobby. Did you have a good spring break? Yeah, that 30-second delay. It's real. I don't know. I'll have to do more research. I wish I could just make it live where it's like 5 seconds or 3 seconds. It'd be so nice. Because I feel like I just sit here and I'm just like, ugh. But regardless, let's go ahead and get started. Feeling unproductive? Um, Things are going well. I think that I'm doing an okay job managing the stress, which, it is a stressful situation. It is what it is. So, I'm continuing to exercise. I am walking the dogs more. I'm trying to be while practicing social distancing, right? Going on a walk is really nice. Uh, obviously avoiding other people, but it's been a good thing. Um, there's a few projects that I've been able to get done around the house. Spring break was really good for that, so that was nice. My backyard looks much cleaner now than it normally does. So I've been trying to, be productive, but, it is what it is. I literally wish I was there in the classroom because I think it's so much fun. But unfortunately, I don't have that ability because everything's going on. So it's all good though. But I'm glad that you're doing well, that you're healthy. I wish that you know you had like a 30-acre plot of land and you can get on that dirt bike and just ride it in circles, right? 30 acres is enough. But all right, let's get into the lesson. So in 70-1, I introduced something called a rational function. We saw a very basic version of that rational function when we looked at parent graphs. Remember, it was like 1 over x minus h plus k. That was a very, very basic version of that. They get more complicated as we're going to examine in this lesson. Now, it doesn't necessarily mean that it's going to be difficult. It's just new. It's just different. And there are a few things that we're going to have to memorize. So the first thing that we examine in the lesson is the domain, because the domain of a rational function has meaning. And if I know what the domain is, I could then take whatever that domain is and break it apart into two different things. One aspect of it is going to be what we call a vertical asymptote. And it's a line that's an imaginary line that goes straight up and down, and the graph won't cross it. It's just going to approach it, and it's either going to go up or going to go down forever as it approaches that vertical asymptote. And then we have another thing called a point discontinuity, or a hole. And the way that we get a point of discontinuity or a hole is when we have the indeterminate case, where it's 0 over 0. So it's still an exclusion from our domain. It's just that 0 over 0 tells me that it's a point of discontinuity, and that's how I can take whatever the domain is and associate it. So this first example right here, this x squared minus x minus 12 over x squared plus x minus 6. So I need to know what my domain is. So it's asking me to identify the domain, vertical, and asymptotes and holes on this graph. So x squared minus x minus 12 all over x squared plus x minus 6. So for me to be able to locate what that domain is, what I need to do is I need to find what makes it 0 in the denominator, right? Because if I divide by 0, that's undefined. So I need to know what makes my function undefined. So I want to set the denominator equal to 0 and solve. Well, it's quadratic, the way that we solve quadratic functions, factoring, and then we also have the quadratic formula. So this actually factors into x plus 3 and x minus 2. And so for right here, I know that x cannot equal negative 3 and cannot equal 2. So then my domain, if I were to think of it as like a number line, it can't equal negative 3. That's an open circle there. It can't equal 2. That's an open circle there. Everything else is going to be shaded. So then my answer is negative infinity to negative 3, union from negative 3 to 2, union from 2 to infinity. So that's my domain. Now, those exclusions from my domain, I can categorize these. I could categorize this either as a vertical asymptote or a hole. The way that we find the holes is if it's 0 over 0. So that means that whatever the factor is in the denominator, something's going to cancel out on top. Because if I plug whatever that value is, you're going to get the same value on top over the bottom. You end up getting 0, 0. So let's factor the top. There we go. So let's factor the top. This top part, this x squared minus x minus 12, that's going to factor into x minus 4 and x plus 3. Now notice this x plus 3 and this x plus 3, they're the same top and bottom. I know that it can't be negative 3 because if I plug in that negative 3 on top here, negative 3 plus 3 is 0. 0 times anything is 0. On the bottom, if I plug in negative 3, I get 0. 0 times anything is 0. You get 0 over 0. So that negative 3, that's my hole. So I have a hole at negative 3. And the way that, like I said, like a shortcut way of verifying it, it's whatever cancels out. So because that x plus 3 cancels out top and bottom, I know that that's a point of discontinuity. That's going to be a hole. Then whatever is left over, so in this instance, this x minus 2, that gave me a 2. So my vertical asymptote is going to be at x equals 2. So these are the three things that the problem is asking me. It's asking me for the domain. It's asking me to find the hole. It's asking me to find the vertical asymptote. Now, always, 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 whatever your exclusions are, you can categorize it either as a whole or a vertical asymptote. They will be categorized as one of those. If they cancel out top and bottom, if the same factor cancels out top and bottom, like the x plus 3, always that's a point of discontinuity or a whole. Whatever's left over, in this case, the x minus 2, whatever that 0 was, which was 2, that is what's going to give me my vertical asymptote. Any questions with that piece? I just noticed... Oh, wait. No, never mind. Yay, 30-second delay. See, I just sang a song. It's probably going to get copyrighted on YouTube because everything gets copyrighted on YouTube. I used to do the intro music. Guess what? Copyrighted on YouTube. It's good that YouTube has those policies, but it's just kind of hilarious. Like, I didn't even think about it. Because I know that on Twitch, they're allowed to play music, and I don't understand how the copywriting differs from that, you know? So that's what's kind of weird. All right, so I'm not getting any feedback, so I'm assuming we know how to do that, or at least it seems like it's not too bad. All right, so let's go into this. First one. It says I identify domain, vertical asymptotes, and any holes. So I have x over 3x minus 6. Well, I need to set, to find the domain, you set the bottom equal to 0. So 3x minus 6 equals 0. Solve, so add 6. Divide by 3. I get x equals 2. And I know it can't be 2 because if I plug in that 2, it's going to divide by 0. So then, my domain, if I wanted to visualize that on a number line, can't be 2. I never said it can't be anything else. So we assume it's automatically everything else. And so that's my domain. Now, I want to see for the points of discontinuity and for the vertical asymptotes, I want to see, does anything reduce? So maybe if I factor out the 3 on the bottom, I'll see something. Okay, so nothing reduces. Because there's nothing that reduces, I do not have a point of discontinuity. So for a whole, not applicable in this instance. There aren't any. Nothing reduces. For my vertical asymptote, whatever was left over after we find our holes, so at x equals 2, I have a vertical asymptote. Any questions on that one? I'm going to look something up real quick while I'm waiting. Because I wonder... There's something I didn't look up. Okay, Let's see if this works. Because I literally just had an epiphany. Okay, good question on what a hole is. Let me pop up on Desmos. I'm going to type in x over x times x plus 2. All right. So if we're looking at this graph, it looks like I guess you can say a normal graph. Nothing peculiar about it. If I look at all these points on the graph, they exist. I have everything. I have all these values on the graph here. Now look what happens when I go over to 0. Now if you look at Desmos here, it even has this open circle. And it says at 0, where x is 0, that's undefined. That's what a hole is. It's basically an instantaneous point on the graph. So it's a singular point or an instance in which you have no graph. Now, when you just look at the graph like this, you can't tell because the line is technically an infinite number of points. And so if I have an infinite number of points on this way and this way, it's kind of difficult to tell that that is an actual hole. I can even zoom in, and it doesn't tell me because it's one of those types of things where it's just there's so many values so close to that 0 in this instance that it's like it's really hard to see. But it's undefined there. Now the reason why it's undefined is because if I said x is 0 and I plugged 0 into this graph, I get 0 over 0 times 0 plus 2. So 0 over 0 times 2. 0 times 2 is 2. I'm sorry, 0. So you get 0 over 0. That 0 over 0, we called that the indeterminate case way back when we talked about lines. And whenever you get that 0 over 0 case, that is automatically a point of discontinuity or a hole. A vertical asymptote is, so we have the domain. Those exclusions to our domain we can classify either as a vertical asymptote or as a hole or a point of discontinuity. So it's one or the other. You'll never be able to do both at the same time. So in this instance, the two exclusions to my domain, if I were to look at this example, x can't be 0, x can't be negative 2. Well, because I have this x over x, those cancel out. Whatever the domain exclusion factor or whatever it is that we're talking about, if that ever cancels out, that's automatically the point of discontinuity because that's what's going to get you the 0 over 0. Whatever's left over, which happens to be this x plus 2, so then that would be negative 2 because negative 2 plus 2 is 0. That right there would represent my vertical asymptote, which is why I have that vertical asymptote there at negative 2. No, it won't always be the y-intercept. That just happened to be this one. Because I could easily have done this. Right? Now my graph is, excuse me. Now my graph has changed a little bit. Right? So this is the graph, obviously, of it. But the factors that cancel out now are the x plus 2's. So that means that, well, the exclusion to my node domain would be negative 2, right? Because negative 2 plus 2 is 0. Negative 2 plus 2 is 0, so you get 0 over 0. So if I go over to negative 2, there's my undefined value. That right there, that's my point of discontinuity. And then whatever was left over, because if those x plus 2's cancel out, I'm left with 1 over x. Well, x can't equal 0. That's my vertical asymptote. And so that's why at 0, I have my vertical asymptote here. Does that clarification help? And same with you, Kylie. Does that clarification help a little better? Yes, that is absolutely correct, Bobby. There has to be some sort of value that reduces top and bottom for it to be a whole. That is the only time that you're ever going to get a whole, which is why on this this question here on number 1, there wasn't a whole because there was nothing that canceled top and bottom. What about you, Kylie? Did that help? I don't know if it'll adjust it for this stream, but I think I might have figured out the whole latency thing, but let's see. Okay, I think that. Perfect. Okay, cool. My creaky chair. All right, so let's continue then. Yeah, I'll just leave that there. Oh. Okay. All right, so let's look at number 2. So number 2, I have x over x squared plus 1. So in a way, if we looked at number 2, since there's only an x on top, then in theory there won't be a whole. That is correct. Now, that is, so there's two ways to look at that. Yes, because it's x, that x will not reduce with anything in the bottom. So that won't, they're not going to reduce at all. So therefore, that's why there's not going to be a whole. But the second reason is if I set my x squared equal to 0 and solve, equals -1, well, that gives me imaginary numbers. So that actually means that there's no exclusion to my domain. So my domain here is actually -infinity to +infinity. Because my domain is -infinity to +infinity, immediately there are no holes. And my vertical asymptotes, there are also none. Or not applicable. You could also say none here if you want. Because there's no exclusion. Let's look at that one on Desmos too. So if I did x over x squared plus 1. So if we look at this, there's no undefined values at all. There's no vertical asymptotes. It just goes on forever and ever and ever. that kind of make a little bit more sense for number 2? Let's look at number 3. So I have f of x equals x plus 7 over x plus 3 squared. For this one here, set the denominator equal to 0. So I get x plus 3 equals 0. Okay, great question, Jocelyn. So imaginary numbers tells us that there's no number that makes the statement true. So going back to this other one, if I said x squared plus 1 and I solved for it, the question I'm asking myself with this equation is, what values for x are going to give me 0? Well, if I solve for it, I'm going to get x equals plus or minus I. Well, because I got imaginary values, that tells me there are no real numbers that for x, so there are no real numbers for x that are going to give me 0. It's not that there's imaginary solutions, it's that there's no real number for x that's going to make that statement true. And so because there's no real values that's going to make that statement true, I'm assuming there are no domain exclusions or restrictions. Does that kind of help does that answer your question, Jocelyn? I know that I'm really sorry about this delay. I tried a couple of things. I'm hoping that the delay is going to get better for the next stream. But so it's not that the domain is imaginary. The domain is all real numbers. It's just when I'm trying to figure out the exclusions of the domain, if I get imaginary numbers, that means there are no numbers that will give me a restriction. Perfect. All right, so let's continue number 3. So for this one here, we're going to subtract 3. And so I'm going to get x cannot equal -3. So that's my domain restriction at -3. That's an open circle. Everywhere else is shaded. So that's going to be from -infinity to -3, union from -3 to infinity. All right, so now that I know that my domain restriction is -3, I have to classify it. Is it a hole? Is it a vertical asymptote? It's one of those. So I check the original problem. Does anything reduce? The answer is no. The factor x plus 7 does not reduce with the factor x plus 3. So therefore, this -3 has to be a vertical asymptote. So I have a vertical asymptote of x equaling -3. And for my holes, I don't have any. Questions on that one? Okay, so let's move on to the next one. All right, so let's look at number 4. So number 4 is x to the 3rd plus 2x squared plus x. over x squared minus x minus 2. That is correct, Bobby. The denominator is what going to determine the exclusions to the domain. The exclusions, because we can't divide by 0 when it comes to a rational expression. Because it's okay to have 0 on top. 0 over 7 is just 0. It's dividing by 0. What is that? We talked about that a little bit more in calculus, actually. And hint, hint, it means you're going towards infinity. And we don't know what infinity is, so that's why it's undefined. Okay, so for this one, to find the domain, right, I can't divide by 0, so I'm going to factor that. That's going to factor into x minus 2 and x plus 1. So then for my domain, it can't be negative 1 or positive 2. So it can't be 2 and negative 1, because if you set each one equal to 0. But I didn't say we can't have anything else, so that's why everything else is going to be shaded. And so for my domain, it's going to be from negative infinity to negative 1, union from negative 1 to 2, union from 2 to infinity. Questions on that part? So all I did was just factor the bottom to determine that. Now there might be something that cancels out, right? So I should factor the top as well. So this factored into x minus 2 and x plus 1. Now on top there's an x in common. So there's an x in every term. So if I factor out that x, I get x squared plus 2x plus 1. And then that actually factors further. That'll factor into x plus 1 times x plus 1. So now if you notice, this x plus 1 and this x plus 1 are going to cancel out. So that tells me that that piece of my domain is a whole. So that means I have a whole at x equaling negative 1. So wherever that x value is at negative 1, or at negative 1, wherever that y value is, that's going to be a whole. And then the other piece that's left over that didn't cancel out, that x minus 2, that's going to be my vertical asymptote. Questions on that piece? I know, a lot of pauses. Just fast forward, fast forward, fast forward. Okay. Let's look at... should I just move on? Do you guys have questions on number 5 or 6? And if you do come across a question on it, you could always answer me in Discord or ask me the question in Discord. Just say, Mr. Duval, this question right here, if you screenshot it with your phone and upload it or something like that, I could then turn in and be like, no, with the answer, and I can upload that to answer your question. Or if you just say, Mr. Duval, in 70-1, number 5, I don't get it. Just saying. Okay, if no one has issues with 5 or 6, let's move on. I would understand that you're speaking for yourself, Bobby. All right, number 7. So it says, find all the zeros of the polynomial, then completely factor it. It's given us one of the zeros, I. So I know I can use synthetic division to be able to divide. So putting I in the box, writing out the rest. For x to the 4th, it's 1. X to the square, or x to the 3rd is -2. For the squared, it's 27. For the x, it's -2, and then 26. So then we're going to add straight down. Multiply 1 times I is I. Add straight down. And then multiply. Okay, well, I'm going to do that off to the side. So distribute. -2i, and then I get plus I squared. But I squared is -1. So that's going to be -1 minus 2i. Add straight down. 26 minus 2i. Then we multiply. Again, I'm going to write that out. So I get 26i minus 2i squared. I squared is -1, so -1 times -2 gives me +2. So this is going to be 2 plus 26 I. Add straight down, you get 26i. And then multiply, you're going to get -26. Because I squared is -1. -1 times 26 is -26. Add straight down, 0. Now, I knew that this is going to be 0, and you could check your work. If you didn't get a 0 there, you did something wrong, because it tells me -1 is a 0. Or sorry, not -1. I is a 0. So I had I squared in my head. Because I know that I is a 0, immediately it should work. So if you didn't get 0, it means you did some math wrong, or you can go back and check your work. So I know that that's remainder. Now, if you remember, we talked about imaginary numbers come in conjugate pairs. So if I know that I have a plus bi, that means I also have a minus bi. So if I have 0 plus I, then I have 0 minus I, which means -I is another 0 that exists in my polynomial here. So I'm going to put -I here, and then I'm going to go through and do the whole dividing again. So add straight down, multiply, add straight down, multiply, add straight down, multiply, and all the i's disappear. So now what I have left over, counting backwards, I have x squared minus 2x plus 26. Does that factor further? Factors of 26 that add to -2? It doesn't. Bummer. So we actually have to use the quadratic formula for this. So -b plus or minus the square root of b squared minus 4 times a times c all over 2a. Uh, 26 times 4 Is that 104? So then 2 plus or minus the square root of a negative 100 over 2. That's 2 plus or minus the negative means I. Square root of 100 is 10. So I get 10I over 2. Now that 2 is going to divide with both of those. So you get 1 plus or minus 5I. So my zeros are I, negative I, 1 plus 5I, and 1 minus 5I. And then it says factor completely. So I'm going to get x minus my 0, x minus my 0, x minus my 0, and then x minus my 0. So it's asked those two things. Completely factor it and find all the zeros. Comments or questions on that one? So this is just review from the last chapter. Okay. So these last ones here, 8, 9, 10, and 11, those are all going to be unit circle stuff. So secant of pi over 6, I'm going to leave this up here just in case you guys have a question. But the secant of pi over 6, well, at pi over 6, my cosine value is radical 3 over 2. My sine value is 1/2. Well, the secant is the reciprocal of cosine. So if cosine is radical 3 over 2, the reciprocal is going to be 2 over root 3, and then we have to rationalize it. Okay, it looks like no one has questions on it. Oh, where's my mouse? I'm scared. I'm scared to move on. Someone's going to ask a question. I just know it. Okay. So the secant of pi 6, we know that the cosine of pi 6 is going to be radical 3 over 2. So that means that the secant is the reciprocal. Now I need to rationalize it. So I'm going to multiply top and bottom by root 3. So you can get 2 root 3 over 3. Cosecant of negative pi thirds. So I know that the sine of that, of negative pi thirds, on the unit circle, that's here. And so that's going to be 1/2 negative radical 3 over 2. So that means the cosecant would be this flipped. So it'll be negative 2 over radical 3, which is going to be negative 2 root 3 over 3. Last one, number 10. And I'll let you guys figure out number 11. So for cotangent, negative pi, 5 pi, so 1, 2, 3, 4, 5. So right here, it's negative 1, 0. Cotangent, well, if tangent sine over cosine, flip that, cosine over sine. That's undefined. All right, that's it. Are there any last questions before we call it a day? And then in tonight's lesson, we go over 70-2, which is talking more about all of the different stuff, rationals, all the precursors. I believe in this one, we talk about horizontal asymptotes, like 99% certain. But I don't want to like say something that yep. Horizontal asymptotes. See, I don't know if the silence is that you guys do or don't have a question. See, now when I type something in the chat, that came up in like half a second. Press 1. See, for you guys, it's so long. I'm counting. It's like 30 seconds. Oh, man. All right, cool. Well, if we don't have any last questions, I appreciate that you guys joined me for this. Like I said, if you come across any issues, please post it in Discord. More than happy to be able to help with that. Other than that, continue being safe, continue making good decisions, and I'll see you